could you open the questions, please? Come on, Miss Sharif. Give me English, please.
I said your laptop on or
It's on. You're logging into Moodle? Well, I know there were 2 questions, I remember that.
yeah. A radioactive sample usually has n equals 10 to the 24 atoms, and A equals minus 10 to the 23. What is the value of the decay constant?
It's like this. Is this part A or something?
Yes.
Yeah. So, you remember we have the form that A equals lambda n?
Minus.
Thank you. So lambda equals minus A over n, which equals minus 10 to the 23 over 10 to the 24, which equals 0.1. Okay. Write that down or correct it if you need to. It's okay? What's the B part then? Activity after 10 seconds. We can use this form then. A equals A0 E minus lambda T, which equals minus 10 to the 23 E minus 0.1 times 10, which of course is minus 10 to the 23 E to the minus 1, which I don't know, it's about 10 to the 22, 2.5 or something, is it? Do you have this calculated, or will I get the calculator? Did you do it the same way?
Yeah.
And what did you get?
The value of E multiplied with 10 to the 23. So I thought it's E to the power 1, not minus 1, because I forget the minus.
Oh, that's the problem then, yeah. It's actually minus 10 to the 23 over E, if you want to think about it like that. Have you got a calculator? Calculator?
I'm to type 10 to 24.
Oh my goodness.
I need a calculator.
You need a calculator tutorial. There we go. Minus 3.68. Oh my goodness, Mr. Sharif. Please fix your mistake then. Well, who's this going to be? Oh dear. Where were you yesterday?
Morning.
I didn't see you at all yesterday.
I didn't come to the morning class, but
Yeah, so where were you?
first in the morning.
I can only use that so many times.
Yeah, so
Oh, indeed. Okay. Do you have this, Mr. Sharif?
Yes.
I can continue with the next one? Well, you need to give me the next one.
Sorry.
Calculate the n.
Calculate the n after 10 seconds?
Yes.
Yeah.
I read.
So you can use this formula, n equals minus a over lambda. I've basically just reused this formula. So that will be minus 3.68 times 10 to the 23 all over 0.1, which equals 3.68 times 10 to the 24 atoms.
And if I use the
I know. Maybe, but maybe not. Sometimes it's not okay in the exam.
right,
Because whoever writes the exam needs to write in the answer, student does not lose a mark if they use the wrong answer for the last part, you know.
I mean if I use the formula saying that n equal n0 e minus lambda t. It is then lambda I have the
But is your lambda right or wrong?
no, I mean if I use the another formula.
Oh, sorry, the other one with the E in it.
Yeah.
Yes, you should get the same answer though. Did you?
No, because I told you I forgot the
Okay,
formula.
okay.
Then you won't get the right answer. So what's your question? Is that okay?
Can
No.
you use the formula?
But if your question is, can you use the other formula? Yes. It's longer, but you can use it. Okay. What's D?
How long until n equals 10 to the 21?
Now we have to use this one, where n is 10 to the 21, and n0 was 10 to the 24, and e was 0.1 t. So we divide both sides by 10 to the 24, and we get 10 to the minus 3 equals e to the minus 0.1 t. We put log on both sides, and we cancel with the e. And we can divide by the minus 0.1, and we have what the t is. Since I don't have a calculator, I'll clean that up a little bit. This will be 3 log 10 over 0.1, so that's 30 log 10. Now I'll calculate. 69 seconds. That's the answer for D. What did you get? Great. Great. Okay. Is there an E or are we on to 2? 2. Okay. Do you need to write anything down from this? No.
A sample of sodium 24 initially has a mass of 10 grams. 7 hours later, there is a 5 gram of radioactive sodium remaining. A sodium will decay by releasing beta particles. What atom will it become after the release?
Okay, so I don't have my periodic table. Na is sodium, but is it like 12?
24,
11. And that will release a beta particle. So that means this here must be 12, and this is still 24. But it's no longer sodium, it's whatever is after sodium. Magnesium? So the answer is magnesium. Okay.
Multiply both sides by n equals n0.
Yeah, this formula we kind of did. So if you have n equals n0 e minus lambda t, these are a number of atoms. So if I divide by Avogadro's number
By the molar mass.
and divide by, yeah, so I'm doing the divide first. If I divide by Avogadro, what have these become? Moles. And then if I multiply by the molar mass, what are you using in chemistry for that? MR? MR for molar mass. Moles by molar mass is mass, yeah. So then you end up with mass equals mass 0 E minus lambda T. A formula you could have possibly have guessed. So that's B. Okay, and then C is probably what is the decay constant? Yeah. So the decay constant I can get by using this formula. We have 5 grams after, how long was it? 7 hours. Now, I could convert these into seconds. But if you keep it as hours, that's okay, but you have to remember that all your time units will be hours. So remember, equals were destructions per second, but then they'd be destructions per hour. I don't know which you prefer, to keep it as the hours or to change it to the seconds. I have a feeling I know, yes, that's what I thought. So we'll change it to the seconds. So that would be minus 7 times 3,600 lambda, 7 hours. Divide, so that becomes 0.5. And then of course lambda, log, and of course cancel, and of course again divide by that. So this would be, can be simplified a little bit. It becomes log 2 over 7 times 3,600. Don't worry if you can't see that immediately, because I just want to type less on the calculator.
Minus 5.5.
No, log 2.
0.5.
I know, but I simplified in my head. 2.75 10 to the minus 5. If you type this in, you'll get the same answer, I would hope.
How can we mathematically change the formula to get the lambda of the t? Like, what happens?
Huh?
How can we make like lambda equals?
Ah.
1%.
Oh, I was using n, wasn't I? So we put m0 underneath, and then log, yeah. And log cancels that. And then divide by minus lambda. And that's what we get. Yes? Now, you've only seen this 4 times actually. Just the 4 times. We did this twice in maths and twice in physics. So I'm only slightly worried that you have to ask me that. Only slightly. Okay. C is... Did you get the same answer? Because you didn't believe that this is the same as this, correct? Yeah. Now I could see it in your eyes. You're like, he's crazy. Do you want to know why it's the same?
Why?
No, do you want to know why it's the same?
Yeah.
Log 0.5 equals log to half, which equals log 1 minus log 2, which equals 0 minus log 2, which equals minus log 2, which cancels this minus. That's what I did in my head. Yeah? Why did I do that? So I wouldn't have to type 0 point, and I could just type 2. It would save me 2 button presses.
Why?
To save me 2 button presses. Because now I don't have to press 0 point. He's laughing, but it's true. Because he doesn't believe me, that's the reason I did this. How many buttons did you have to press? You had to press 2 more buttons than I did. You had to press log 0.5. And you also had to press a minus, so you actually have to press 3 more buttons than me. I just have to press log 2.
Okay.
Yeah.
Smooth.
Right. D now.
Oh god. How long until only 10% of the radioactive sample size is remaining?
So if there was 10 grams at the beginning, how many grams do you want now? 1 gram. So that would be 0.001 equals 0.010 E minus lambda T. And we're looking for the T here, isn't it? So if we divide by 0.010, we'll get 0.1 equals e minus lambda, which I know. I'll just write lambda for the moment. What should I do now? Log and log. Cancel, cancel. Divide by minus lambda. Again, by the same trick, this becomes log 1 minus 10. Log 1 over 10, log 1 minus 10, which becomes minus log 10. Cancelling with the minus there means that t equals log 10 over lambda, which we said is 2.75, times 10 to the minus 5, which, if you want to save even more typing, it comes up to the top to be 10 to the 5. So, you have log 10 divided by 2.75 times 10 to the 5. Now, probably should put this into hours since it's so many seconds. So nearly a day, 23 and a quarter hours. 23 and a quarter hours. So it's roughly a day. So I'll say about 1 day. Yeah. Is there any part? No, that was the end of it? Yep. Okay. Let's have a look at some exam questions, and let's see this one in the exam. So, were any troubles with this? Any major problems? Apart from silly mistakes, maybe? No. No. So, it's, I think, a good exam question. I remember I was telling you before that, in my opinion, atoms is maybe the best exam question. And I still think that's true. What do I want? Past papers. Let's see. What have I got? I don't have, for some reason I don't have last year's 2015 to 2016, maybe this is. Anyways, we'll see what atoms question is in this. You for sure have it somewhere in A or B. Let's see. No. Yes, but we haven't done this part yet. No. Yes, but we haven't done it yet. Mechanics, materials. Here we go. Here's a great one. Oh, but we actually haven't done the A part. Yes, I don't think we've done the A part. No, we haven't done the A part yet. Now, I think we'll do the B part now. And please read it carefully. They're trying to trick you. Well, I guess it is right to say they're trying to trick you a little bit with the English in this question. Because the atoms is kind of a straightforward question, I mean, we haven't done many formulas. We've only done A equals minus lambda n, and then the exponential formulas. I think they're trying to complicate this a little bit with the English in it. So I think you should be able to do this one in only like 3 or 4 minutes, because there's not a lot of maths in it. But what might catch you out is the use of English in the question, okay? So I'll just give you a minute to try this one, and then I'll do it here. Just the B part here of this question. I'll read it for you. A patient is given a drink containing a low dose of iodine 123 in order to study the uptake of the iodine by the thyroid, which is here. The initial activity is 11.2 megabq. If 50% of the iodine 123 has entered the patient's thyroid after 10 hours, determine the activity of the iodine 123 in the thyroid at this time. Okay. I'll give you a minute or two to try the part here. And then part 2 is what is the time until there's only 2 megabq left. So this one will be an exponential formula like we were doing today. Yeah. The English, yes. Now, no Arabic. only English, but you can work together, of course, to try and figure it out. But please note, it's 6 marks in total. Think you got the part 1 done?
The decay constant. Where is the decay constant?
Huh?
Where is the decay constant?
Where is the decay constant?
Yeah.
Everything is given in the question. Now, actually, do you know what? I think the previous question had you calculate something which you might need for this one, the decay constant. So, since we can't do part A, I'll just look it up here for you, okay? But just do your calculations, but leave the decay constant in it, and then at the end I'll give it to you to type it in then. Or maybe a quick Google might give it to you there, decay constant of iodine 123. Does it list it? Oh, it's on Wikipedia.
Can I go back?
No, I'll just type in decay constant. It's not on this page, but I know where it's calculated. Okay, you can close that now. 13.32. Okay, if you need it, this is the decay constant on your screen. Well, no, you do need it, of course. Don't need my internet now. English.
Not yet. We're gonna divide the answer by
You feel you have an answer for part 1, huh?
yes, got that. 10 hours, 10 multiplied 3,000. Divide the answer by 50%.
Go for it. What do you think your answer is?
3.
Zero.
Yeah, but we're in mega, so divide by 10 to the 6th. Do you get an answer of like 3.33?
Yes, 3.3.
Yeah. In my head, I was estimating an answer of around about 3, so this seems like you got it right. Let's check the exact answer here. So good job, you figured out their sort of sneaky use of English here. There's some iodine put into the person. Let's calculate the activity after 10 hours. So the activity after 10 hours is A0 E minus lambda T. What was the A0? Or is it not given? No, it is.
11.2
Mega. And then the lambda we have here as well as 1.45 times 10 to the 5 times 10 hours, which is 36000.
10 minus 5 lambda.
Thank you.
And 10 hours.
Yeah, that's 36000 seconds.
Okay.
11.2 times 10 to the power of 5. Although I know the answer is going to be in mega, so I won't even bother. E power minus my answer before times 36000. No, not finished yet. So that's the activity is 6.656 after 10 hours. However, here's the person's neck. The iodine is in their body, but only half of it is actually in the part that we're interested in. So we literally just have to divide this by 2, because it's like we throw half of it away. We don't care about the part outside the thyroid. So if I just take this answer and divide it by 2, I get 3.33. Mega, sorry, B equals. Yes?
This is the activity.
This is the activity, yes. So you got this answer. Very good. 3 marks. Not too bad. Do you see what I mean by, sorry, just a second. Do you see what I mean by they tried to complicate with their 50% after 10 hours is in the thyroid? You know, it's a bit sneaky, Yes?
If they asked for the lambda, for example, and they said after like 50% of the lambda will still be the same.
Yeah, it's a constant, decay constant. Yeah. Right, next one.
Why did they change?
Huh? Why did they change lambda?
No, they.
What do you mean, change the A?
Yeah, I thought it was like constant, like.
The activity?
But
No, the activity decreases and the N decreases. Only the lambda is constant. Yeah. Part 2 you actually should find familiar because you've done it like in your homework. It's what's the time until this activity decreases to 2 megabequels? No pen, no paper, Adnan, or paper?
yeah.
Where? Are you speaking English?
Mm.
Ah, Miss Sharif, come on.
I can't.
You're speaking English right now.
No. We start to talk English, but after 2 sentences we change language.
English. Focus on English.
Sounds to talk with
I know.
someone who talk Arabic.
Right. Oh, so it's Iyad's fault. Oh, I see. You see how quickly he hung you out to dry.
Sorry.
No, it's really hard.
As soon as things go tough. Oh no.
No.
Hey, no, you can't take it back now.
No, it's not something wrong
No.
because I can't.
I think it's something wrong. I want English.
Yeah, but it's not. I don't mean to talk in Arabic with Yad because you want me to talk in English. You know.
Try harder. Be
Yeah.
strong.
Yeah.
You got an answer yet? Your answer should be pretty big if you're using seconds, so it might be useful to convert it to hours at the end.
You actually need that time. Not until 15 to over. I don't know.
Yes.
Got an answer there, guys? OMG, Musharif. That's better. What answer are you getting there, Iyad? That seems so wrong.
No, we're just getting it in hours already. That's
And how many hours did you get?
Yeah,
No, roughly. What are we talking about?
no, I really forgot.
Oh.
We're doing it again.
You don't remember if it was hundreds of hours, or tens of hours, or a couple of hours?
No, it was to the minus something. So.
Oh, goodness.
Yeah.
That's a problem.
It's log 2. Okay.
What time did you get, guys? Don't be shy. What time did you get? Tell me. Even if it's a crazy answer, what did you get? Because maybe I'll figure out your mistake.
It's minus.
That's time is minus. Go on. What did you get? Minus. Come on, you're killing me here. What time did you get? Yeah. No. Let's have a look now. So here, what is the activity at the beginning? Now you have to be careful here again with the English, because it says determine the time taken for it to fall to 2 megabq. So it's almost like we're now starting at 3.33 and we want to decrease it to 2. Well, anyways, I at least hope you use this formula.
Yes.
Good, okay. So here is here is 2,
Yes.
and here is 3.33. Now, if you didn't use 3.33, what did you use?
We use the initial A0.
Yeah, now it gets a bit complicated there, because if you use A0, you also have to divide it by 2, because only half of it is in the thyroid, and also 10 hours have already passed, so you'd have to minus 10 from your answer. It's too messy this way. Instead, it's much better to think about it starting here with the right amount and forget about the other 50% and look at the decrease from here down to 2. Simplifies your life. So this would be e to the minus lambda t. Do we know lambda? Yeah, so we'll divide by 3.33 and this is going to be roughly equal to 0.6, I believe. So if we log both sides and then divide by minus lambda, this would be log 6 over 10 log, yeah, I can't read, no sorry, this log 0.6 is log 6 over 10, isn't it? Which is log 3 over 5, which is log 3, yeah, so it doesn't simplify nicely here. Minus log 0.6, and what was the heck? Oh, stuck. Oh, because my battery's about to go to standby, I think. Do you mind typing in log minus log 0.6 over the decay constant with just a decay constant? I have it here now, actually. Just about got enough power. So you get this one, yeah, divided by 3,600, yeah, 9 3/4 hours. So it's nearly 10 hours. Oh my God. You're standing up before 10 hours, roughly, is the time. Now, does it ask for the answer in hours? I think they'll take the answer in hours, of course. No, so 9 3/4 hour roughly. 6 marks isn't really that bad. It's actually kind of good, I think. And the A part, we will do it soon, and you'll see that the A part's actually pretty easy because you can see from a look at it quickly, it's just a graph question. The type of graph question you would have done in electricity when you were doing capacitors. Right, now, Musharif.